This is a super sweet FPV drone, and it's super awesome to fly. And maybe you don't fly FPV drones, but maybe you fly RC airplanes, and they're super freaking fun, and I know that. But guess what? These don't do anything if you don't have these. This is a big old battery. You probably don't need this battery, but this is a battery. It's a LiPo battery, and that's what these drones and RC things run on most of the time. But you can't just slap any old battery on there. You got to know what kind of battery you need, and you know what that's it. You got to know what kind of battery you need, and there are a lot to choose from, and it can be very confusing. So in this video, I'm going to explain what all the numbers and letters mean on the battery, so that way you can confidently purchase a battery, fly a battery, and take care of a battery without burning anything down. Hey, bottom line up front as usual, if you just want to know what kind of battery you need to get for your new drone that you bought, I'm going to save you some time. You don't have to watch this video because it's chock full of information and that takes a little while. Just go to the drone manufacturer's website or the listing on the store that you bought it from, and it will probably say what the recommended battery is, and maybe we'll even have a link to where you can buy it. That's the best way to make sure that you get the battery that probably is going to work the best for your drone. But you'll probably need to learn all this battery stuff anyway, and it will benefit you in the long run. So stick around, and I'm going to teach you all that stuff right after a word from our sponsor for today's video, PCBWay. PCBWay makes custom printed circuit boards. That's what PCB stands for. And they have thousands of components to choose from, and circuit board materials and types, and all of the pieces that go on the circuit board. In fact, they even have a service where you can send them your design for the circuit board. They can take all those parts and pieces, stick it on the circuit board as you wish, and then test it before it even comes to your door to make sure that it works. I think that's pretty cool. But if you don't like circuit boards, I mean, who does, right? Some people do. Anyway, that wasn't necessary. Moving on. But if you don't like circuit boards, that's okay. They offer rapid prototyping services, so you can make cool projects like I do. They offer sheet metal bending, CNC machining, injection molding, and 3D printing in various types of materials in all of those processes. So if you're working on a cool project and you don't have the materials to make what you want, you might want to check out PCBWay.com. I'll leave a link to them down in the description below this video in case you're interested. Now let's get to some battery stuff. There are 6 very important things that you need to know about the type of battery that you're going to get, okay? Don't freak out. It's not too complicated, and some of it's very obvious. Number 1, you got to know what kind of chemistry the battery is. That's pretty simple. Most of these batteries that we use with FPV drones and RC aircraft are going to be lithium polymer batteries, or LiPo batteries for short. Now, there is lithium ion. That's the next most common type of battery. Lithium ion is becoming more and more popular, so that is an option, but I'm not going to focus on it for this video today. We'll do that in another video. But just to give you a basic idea, lithium polymer batteries are great because they pack a lot of power into a very relatively lightweight package, whereas lithium ion batteries, they will fly for longer but won't have as much punch. And when you're ripping around an FPV drone, you want punch. So that's the first thing out of the way. We're looking for lithium polymer or LiPo batteries. The next most important thing is voltage. All right, what does voltage do for us? Well, here's the thing. We need to know how sort of powerful the battery is. All right, how many volts it has. Now, the voltage is basically going to be directly related to thrust or speed. So more volts means motors go vroom vroom more, usually vroom vroom more good. But if you have too many volts, motors go poof, and electronics go poof, and magic smoke comes out and they get fried. Okay, so you need to stay within the voltage range that your electronics and that your entire quadcopter is made for. When you purchase a drone or drone components, it will say what the voltage is that it's rated for. Now, the way it's going to tell you this voltage is usually with a number and then the letter S. So what that stands for is the number of cells in the battery. So a 1-cell battery would be called a 1S battery, 2-cell would be 2S, 3-cell would be 3S, and so on. The S stands for how the batteries are wired, which is in series versus parallel, but I've really never come across these types of batteries to be wired in parallel, so don't worry about it. Just pretend that S stands for cell. Now that we know we need a LiPo battery and of a certain kind of voltage, the next thing we need to know is the capacity of the battery. Now, the capacity, you can think of this like the fuel tank. This is directly related to how long you can fly your drone. The capacity of the battery is measured in milliamp hours. Now, really large batteries, like maybe your car battery, is probably measured in amp hours, but these batteries are so small, they're measured in milliamp hours. So, for example, a 1300 milliamp hour battery would be equivalent to a 1.3 amp hour battery. That little tidbit will come into play later on when we talk more about this. So, what capacity battery do you need for your drone? Well, generally speaking, the more capacity it has, or the higher the number of milliamp hours it has, the longer it will fly. But the thing is, that directly increases the weight and size of the battery. So, you need to stick within a nice balanced range for your particular drone. So, for example, if it's a 5-inch drone, which is like the most common size, you could go anywhere from like a 1200 milliamp hour to maybe a 1800 milliamp hour battery. On the low end, it's going to give you a lot of performance and maneuverability because it's lighter, but it won't fly as long. And on the other end, you'll be able to fly longer, but it will be heavier and maybe won't handle how you want it to. So it's kind of personal preference. And the important thing is going to be the paying attention to the voltage in flight to make sure that you're not going to fall out of the sky suddenly. We'll talk about that in a few minutes. Okay, so now we know we need a lithium polymer battery of a certain voltage with a certain amount of capacity that's the right size for our drone. And now the question is, what is this C rating that I keep hearing about? On the battery, it'll say 100C, 60C, 75C, or 100C 120 burst. What is going on? Basically, the C rating is a measurement of how quickly the battery can be discharged or charged safely. Now, when we're flying, we're worried about discharging the battery. So essentially, a high C rating should allow the battery to deliver more amperage for a longer duration. And this becomes important if you're racing drones where you're pretty much at full throttle the whole time. That means that it's a really big deal to be able to basically give as much power from the battery as quickly as possible for as long as possible. So if you're just doing some like cruising flight and you're not racing, maybe doing a couple punch outs, you don't really need a super high C rating. So really the most important thing to keep in mind is just that when you're shopping for batteries, don't purchase a battery that's really made for an RC airplane, which will have a lot less amp draw, which might produce maybe 20C or 30C. Go for one that's made to deliver at least, I would say, 60C continuous or more. Now, sometimes they do list the regular C rating and then a burst C rating. For example, the battery might say it can deliver a 60C rating continuously, but then it can do, 100C burst, and the burst might just be a few seconds. Okay, but what the heck is the actual C? All right, what the actual C means, I can't remember what it stands for. Current, probably, constant, something like that. That doesn't matter. What matters is the way you find the actual amperage that you can draw from the battery is using that C rating. So if a battery is labeled as a 60C battery, what you would do is multiply the milliamp hour capacity of the battery times the C rating. Now, what you want to do is change the milliamp hours and turn them into amp hours. So to convert milliamp hours into amp hours, what you want to do is essentially move the decimal place from the end of the numbers 3 spaces to the left, and then you get amp hours. So for example, a 1300 milliamp hour battery would be 1.3 amp hours. So if we wanted to figure out how many amps this battery could deliver at 60C, we would do 1.3 times 60, and we would get 78 amps. Now that's just one example, and that is kind of towards the low end of what most of these batteries are made to deliver. Bottom line, basically, the higher C rating, the better, but don't worry about it too much. In fact, once you really start getting into the battery stuff, you might actually want a lower C rating because it tends to make the battery actually lighter when they manufacture it, which could be better for your flight performance for your particular drone. Okay, you're probably sick of hearing the word C or letter. Is it a letter? It's a letter. Okay, so let's move on. Finally, we have two very important physical factors of the battery, which are the connectors. Now, every battery is going to have two different types of connectors on it. It's going to have the balance connector for charging the battery, and then it's going to have the main power lead, which will be how you charge the battery, but also how you plug it into the drone. And that's very important because you want to make sure when you buy a battery, it has the right connector for your drone. The most common types of connectors are going to be XT30. That's usually for a smaller, maybe 3-inch or 2-inch, something like a much smaller drone. Or the XT60. That's going to be the most common for anything from like a 3-inch size up to a 7-inch size drone. Now, some smaller drones, especially micro drones, may have a different type of connector altogether because even the XT30 might be too large for like the really little tiny whoops and whatnot. And just to recap, the most important things when purchasing a drone battery are going to be the voltage, the connector type, and then the capacity. So now you know what kind of battery you need, you bought the battery, and now you need to charge it. Now, some very important safety stuff needs to be told to you right now because these batteries can not really explode exactly, but they can catch on fire and burst into flame if they are mishandled or mistreated. So if you take a knife and you stab one of them, the metal is going to cause a bunch of contacts to happen between the little cells, and then it's just all the amperage is going to go off all at once. Okay, so instead of like a little bit at a time like it's supposed to be, it's just going to start venting gases, and those gases could burst into flame essentially. So bad situation. All right, so don't stab your batteries. How many times I have to tell you guys, don't stab your batteries? Not only do you need to not stab the battery, you also need to avoid overcharging the battery. Okay, so it's very important that you pay attention on that charger that you got and make sure that it's set for a lithium polymer battery, and you want to make sure that it is set for the correct voltage range. Now, when it comes to charging, it's very important to know the voltage for each cell in the battery. It just so happens that the voltage tends to be basically from a minimum of 3.2 volts to right about 4.2 volts. That's for a standard lithium polymer cell. If you go below 3.2 volts, you're probably going to be doing damage to your cell because you can over discharge these cells. And if you go above 4.2, you're probably doing damage by overcharging. And that is really what you have to watch out for when you are charging your batteries, because if you overcharge, then you're pumping way too much voltage goodness into that battery and it cannot handle it, and it will just burst into flame basically. It has happened to a lot of people, and if you're not smart, it will burn your house down. So be smart, okay? Charge in a safe, non-fire flamey area in the garage, on a concrete floor, or on a metal work surface, or something that is not just going to burst into flame and then catch other stuff on fire. When you are charging, you can put your battery in a LiPo bag, is what they're called, basically a fire resistant bag that's made to hold the batteries. That tends to be not the great option to me because it is just a little awkward to try and get the battery in there and the charger and stuff like that. So what I prefer to do is I have a metal suitcase that I put all my charging stuff in there, and then I can just close the lid most of the way. There's still a little bit of airflow, and that way if there was any kind of flame or heat or something like that, it should be contained within that metal case. Chargers. There are a lot of different options for chargers, all the way from like very, very cheap to very, very expensive. I don't have a recommendation for you right now of what charger you should get as a beginner, but I will have a link to something that I can recommend for you in the description below this video. Now, the good thing is most chargers are smart enough that you can plug your battery in there and either it will automatically detect the cell count, which I don't really recommend you do, but you can just put in how many cells the battery is supposed to have, and then it will know what voltage each cell is supposed to be. So you don't have to like sit there and tell it to do each cell and all that kind of stuff. You just tell it what kind of battery you have, how many cells, and then it will take care of the rest. But always, always, always use that balance cable. Use that, because what that does is essentially charges up all the cells so that they stay at the right level. Because if you don't have that, what could happen is you have one cell that is just not charging, and so the charger thinks that it needs to put more electricity into the battery, but it really doesn't, and then it ends up charging the other cells too much. So that balance cable is there to make sure all the cells come up at the same time. And not only is it safer, but your battery will perform better when all the cells are kind of equalized and ready to go. Now, one thing that you will need to set on your charger is how many amps you want to charge the battery at, okay? Generally, what I would do is charge it at a 1C rating. There you go again, there's that C rating. So what that means is essentially convert your battery milliamp hours into amp hours. So again, just kind of move that decimal place over to the left 3 spaces. So that 1C rating for a 1300 milliamp hour battery would be 1.3 amps. And most manufacturers recommend anywhere from 1 to 5C. I think most of them don't recommend 5C. Really, I usually only charge at 1 to maybe 2C. And the reason why you do the C rating method is because then the amperage changes with each battery. And so generally speaking, the larger the battery, the more amperage you can put into charging the battery safely. Okay, but if you have a little teeny tiny 300 milliamp hour battery, okay, and you try to charge it with 3 amps, that would be like a 10C rating. Also, I should mention that high voltage lithium polymer batteries are becoming more popular. High voltage lithium polymer batteries pretty much treated the same, except their cell voltage goes up to 4.35 volts per cell. So you can charge a little bit higher voltage per cell. Most chargers should have a setting for the high voltage batteries. So you just select that you're charging a high voltage battery and it will automatically know that it needs to charge each cell to 4.35 volts. But it's very important to not accidentally charge a regular lithium polymer battery like you would a high voltage cell. All right, now your battery is nice and charged and it is just ready to go. So you slap that baby on your quad and you plug it in and you go fly. Now, should you A, fly until you fall out of the sky, or B, make sure that you are monitoring the voltage on the OSD? Yes, you should fly until you fall out of the sky. No, I'm just kidding. Check that voltage. This is a really important thing. Now, most FPV drones, because they are FPV, we have the goggles, will have the on-screen display pretty much standard, okay? So that's where you have information about the drone and most importantly, the voltage of the battery. So what I like to do is have the full voltage of the battery and then the average cell voltage of the battery, because it's just easier to pay attention to that little number. So what you want to do is when you start out, that average cell voltage on your OSD screen there, it should be right about 4.2. It'll probably drop down a little bit because now it's, some voltage is going away because it's powering the drone. But you want to make sure that when you end your flight, that you end it with about 20% of the battery voltage remaining. Now, I know it's like, I got this battery and like it's supposed to, give me this much, but then I gotta like not fly it until it's empty. Well, yeah, that's basically the case. It's kind of like with your car. You really shouldn't run it until it's empty. You want to save a little bit and then, refill it, okay? And that could be really important because, maybe you're flying far away and then you realize, oh no, my battery's low, and then you need like that extra little bit just to get you back. But also, not draining your battery all the way for every flight will increase the lifespan of your battery. So if you treat it better, it will last longer. So 20% of the battery voltage is going to be about 3.7 volts per cell. If you go much below that, it's really going to start to drop off a cliff. I would not want to land with anything less than 3.5 for sure. Now, your voltage will typically come back up because the voltage sag of running the motors tends to make it go down, but then once you land and you shut off, the voltage should kind of come back up. And so you won't actually be in as bad of a situation as you might have thought, but that's why you want to end with a reasonable amount of voltage and not take it way down, because that's how these lithium polymer batteries are made. They're made to really deliver a pretty consistent amount of voltage, and then they'll just drop off a cliff. And the reason why is because they're made so that we can get really good performance and consistent performance for a short duration, and then we can come back, swap the packs, and then do it again, instead of basically getting, you know, some usable voltage for a longer period of time. And that's actually kind of what lithium ion packs do, and we'll talk about those in another video. So my recommendation, once your battery average cell voltage is about 3.7 volts, why don't you bring it on back, land, and put another pack on there, and that way it'll last you a lot longer in the long run. And if you over discharge your battery, you may notice that it will start to get puffy. People will talk about like their LiPo puffed. And that is a bad thing. That means that the battery has been over discharged, and the cell, it could even be ruptured or damaged in the sense of it's doing, like, you know, chemistry stuff, and it's causing it to puff up. And that's a very sure sign that your cell is no longer as good as it once was, and you should probably stop using it. So that's another really good reason to not drain your battery all the way, because it's important to point out, which I just realized that this may not be super obvious, these batteries do not have any kind of a safety protection or low voltage shutoff. Most of them don't anyway. And that is nice because it keeps the cost relatively low or lower. And it allows you to be the one in control of, you know, if you, like, let's say if you were coming back, you're flying back, maybe you're flying over water or something, and you really got to just drain that battery all the way just to get back safely. You want to have the option to do that instead of, you know, your low voltage protection kicking in and being like, oh no, we want to save the battery, and then your drone ends up going down, you know, in the ocean or something like that. So that wouldn't be good. So you are in control of keeping the battery alive. Congratulations. I hope you do a good job. And one more thing to keep in mind, once you are back on the ground and your battery is discharged, what you probably want to do is either charge it back up to about 3.8 volts, which is going to be a nice resting voltage for the battery, or like a storage charge, they call it, if you know that you're not going to use the battery for a while. Or you can just recharge it and then go fly it again. But I definitely would not leave the battery fully charged for very long or fully discharged for very long, because of the way the chemistry in the battery works. It likes to be at you know, 3.8. And I know somebody's gonna be like, it's a battery, it doesn't like anything, it's just an inanimate object. Well, guess what? It's easier to understand if you say that something likes something, because you're anthropomorphizing it, okay? So there you go. So do what your battery likes and treat it good, and it'll treat you good, okay? Okay. Did I miss anything? Maybe. If I did, leave a comment down below. But thanks so much for watching, and I hope this helped you to be able to confidently purchase, take care of, fly, and just use batteries without blowing things up or anything like that. Comments, questions, welcome down below. Thanks for watching, and I will see you again very soon.
We get bars in our goggles.